So, what we're going to be doing today on this lesson is calculating the percent composition of a hydrate. So we've been doing percent composition and we have been talking about empirical formulas for compounds, and this is going to tie in the empirical formulas plus percent composition. So I'm going to go ahead and run through a few of these and show you how it works. So this one, you have a 2.5 gram sample of a hydrate of barium chloride, and it is heated, and 2.15 grams of the anhydrous salt remains. What percent of the water is the hydrate? So let's talk about what we have here. So first off, we have barium chloride hydrate. Now I'm going to put just a N there because it doesn't tell us what that N value is. So it could have 1, it could have 2, 3, 4, we don't know. But it does tell us that the hydrate, the barium chloride hydrate, so I'm going to come down here, weighs 2.5 grams. So I do know that to be true. And then it says that I heat it, okay? So I heat it. And when I heat it, what happens is that I get rid of the water, okay? And I don't know how many grams that is, but I get rid of, okay? I'm subtracting off, I'm evaporating off the water, okay? And so what's left in the container is just now the barium chloride, and we call that an anhydrous salt. Okay, and so that would be the number of grams of anhydrous salt that is left over. Okay, so that's what we're looking at. So again, what we have is something that contains water. We have 2.5 grams of it, and then we are going to evaporate that water off. All we're left is the salt. Okay, so hopefully you can think of that. Maybe the easiest thing would be to think of if you had a container of salt water and you let it set, then you know you would have that residue that was left in the bottom, and that's what we're talking about. You would have that salt left over. Now, when we have it left over, it tells us there's 2.15 grams that is left over. So the question becomes, if you started with 2.5 and I have 2.15 left over, how many grams was salt? Okay, and hopefully you realize that you needed to just subtract the 2.5 and the 2.15, and we get 0.35 grams of water we lost. Okay? Now, the next thing it wants to know is, what is the percent of water of the hydrate? Now, it doesn't say what's the percent of salt or what's percent of the whole thing. It wants to know what percent is water. So again, remember, to find percent of anything, it's how much of that I have. So in this case, it's the grams of water always over the total, okay, that I started with. And so I'm asking what percent of water is of the barium hydrate. So my mass of my water is 0.35 grams. My total mass that I started with was 2.5 grams. And I can just divide that on out and find my percent of water. Okay, so in this case, 14% of it was water. Okay, final answer there. Okay, so number 2 is going to be exactly the same problem. Let me slide this on up here. Okay, same problem. Over, which was the calcium nitrate, amounted to 3.4 grams. So this was our salt. Okay, so again, I want a percent of water. So figure out from that information, look at your problem that you had above, and how would we find the percent of water? And go ahead and calculate that out. Okay, let's see if we agree. So that would mean that 1.7 grams was water. I do a percent composition, so set 1.7 grams of water over the total of my hydrate, gives me 0.34, or 34% of it was water. Okay, let's go on to number 3. Okay, so this one's going to give us a little bit different. So it says a student heated 5 grams of copper sulfate pentahydrate until all the water of hydration was expelled. How much mass will the sample lose? Okay, so we want a mass, will it lose? So what is it losing? What did we say earlier we were losing? Okay, we lost the water, right? So in this problem, I don't need to know what percent of water, but I need to know the grams of water. Okay, the grams of water. Now, this problem is different in the fact that they tell us there's 5 waters on there. Okay, so we can actually find what percent of this hydrate is water, because I know each one of these has 1 molecule or 5 molecules of water attached to it. Okay, so let's start off with our formula. Copper sulfate, 5 waters, and we actually need to find 2 different things, right? Because if I want to find, in this case, the percent of water, because I'm going to have to find the percent of the water, because that's what percent it is of the 5, before I get started. So again, remember our percent of our water was our grams of water over our total. Okay? So we need to know our total, and we need to know what percent is water to get our grams. So we're kind of looking at it from a different angle. Up here on this problem, we knew our grams, we knew our total, and we were finding our percent. So we're just looking for something different. So we need to take this value and find the percent of water. Percent of water. So let's talk about how to do that. We need to find the total mass, that means of everything. We're going to need to find the mass of our 5 waters, and then do part over whole. Okay, now be sure when you count your total mass, let's talk about that. Total mass of a hydrate. Okay, now you can do it several ways. I have a copper, a sulfur, and 4 oxygens. So you might want to look at it in 2 parts. And then I have 10 hydrogens here and 5 oxygens here. So I might want to look at it in 2 parts. Okay? So go through and find out what is the mass of the copper sulfate. What's the mass of the water? And then we can always add these 2 together to get our total. Okay? So go in and find your mass. Okay, so see if you agree with me. I come up with that the copper sulfate was 159.61. I come up with the 5 waters was 90.08. So that means that my total of my compound is these 2 added together. So that would give me, put those 2 together, 249.69. Okay? And I want to know what percent water is of that. So water is 90.08. So I got to do this step first. And let's get our percent. So 90.08 divided by 249.69. That means 36%, 0.1% is water. Okay, so now our final step, because we want to know how many grams is water. So what this is saying is 36.1% of the 5 grams is water. So hopefully from math class, you know that you do 0.361 times, of means times, 5.00. And we're going to get, and we've got 3 decimal places, 1.80 grams of water. Okay? So let's look at number 4, because this one, we're looking for the N value. What value is N? Okay, where the previous problem, it was 9. So again, here we go. You have a 5.0 gram sample of copper nitrate times NH2O. We're going to heat it, okay? We're going to heat it. We're going to lose the water. And you have 3.9 grams of the salt left over. So I'm setting this up just a little bit different than I did before. 2. Okay? So again, I want to know the value of N. The value of N is going to be somewhat of a mole ratio similar to our empirical. So let's talk about it. So these problems have all kind of been related together. So I can figure out how many grams of water was released, right? 5 minus 3.0, which means that I lost 1.1 grams of water. Is everybody okay with that? 1.1 grams of water. Now, since I want this N value, again, it's kind of like the subscripts on an empirical formula. So what I need to do in this problem is I need to take my 1.1 grams of water. I need to take my 3.9 grams of copper nitrate, and I am going to do an empirical formula. The only difference is when I get those mole ratios over here at the end, they're not the subscripts. They are, in fact, the values that go here in the front. Okay? So let's just do a gram to mole conversion. Okay, so let's just check to see where you're at. So what I did was a gram to mole conversion for both my water and my copper nitrate. Again, I did have to calculate out my copper nitrate because I can't just find that on the periodic table. So I actually had to go do over to the side a calculation for it, very similar to how I did my copper sulfate. Then I divided it out and found my moles. Now, of course, the next step is going to do that mole ratio. Pick which one of these is the smallest. So in this case, H2O is going to be 0.061 divided by 0.021. And so when I divide that out, I should get roughly about 3. So I get 2.9. But again, I can approximate that to a 3. I now do copper nitrate. And again, it's going to be divided by itself. And when you're doing a hydrate problem, okay, your number in front of your copper sulfate will always be a 1, always, or whatever you happen to have, whether it's copper nitrate, copper sulfate, whatever it happens to be. So in this case, we have a 3. So this formula is CuNO3 2, it's not times, H2Os. So this is copper nitrate trihydrate.